Okay, so essentially, like you can see, like you probably all of us have performed a cross join accidentally. Um, so a cross join is just when, and we can do like just like a select star to show you. So we just do select, we do a select statement, and then you do from, and you just join the two tables, but we don't specify what is the join key. All right. So as you've probably seen the result of something like this, essentially every combination, right, is returned. So we see Mo is paired with every one of the different customers, right? Bart, Maggie, Lisa. Selma's paired with all of those customers. Bart, Maggie, Lisa, Patty. Okay? Bart, Maggie, Lisa. So you can, you can use a cross join to basically generate every possible combination between either two tables. We'll also show how to do it with one table. So maybe the question then is like, why would what is the use case for something like this? One use case is like, you can just think of cases where you do want to see all possible combinations, right? So one might be like if you run a clothing store and you want to know like, okay, what's all the inventory you need to kind of, have, or what's all the possible inventory that you should consider, right? Maybe all the purchases. We would want to maybe perform a cross join of all the sizes and all the colors, right? Or you can think of different variations of this, the sizes and the brands, or types of clothing, right? Things like that. So like generating every possible combination can be pretty useful. This is here, right? Like having the hour, the minute, hour, minute, second, right? And like what happened, or very common, you might in a table want to have a row for each like day of the month. Or like maybe every hour for every day in that month, and then break down your data by that, right? That's called like, you can create, I think it's called like creating like a spine of the data, right? And then you can perform analytics on that spine. So that's like another use case. In LeetCode problems, oftentimes, it'll be pretty straightforward if you see this of like generate all possible combinations. Sometimes, like you'll see, and we'll build up to this, you'll see a use case where you have to really join the table with itself. So what would be an example of this? Let's say we have, students, and we want to, pair each student with each other, right? So like, how do we do something like that? It's not bad once you know the trick. So what I'm doing is I'm doing select all, right, from customers C1. So I'm giving it an NL, and I don't have to do that. I think maybe I do because it's the same table. Customer C1, join customer C2. Okay. Now this looks maybe pretty good, but it's not great because you can see right away I'm pairing Bart Simpson with himself. Okay. And then another issue is, let's think about this. So I have Bart and Maggie. I also have Maggie and Bart. Okay? So I'm getting actually the data duplicated. So one way to deal with this, let's just first see how to remove Bart with himself. I can say where C1.id, right? The ID I think is probably the same. Or if you want to be certain, you could do like C1.name. And this does not equal C2.name. All right, and now right away you can see I'm no longer pairing Bart with himself. But an issue is that you still have this issue of Bart with Maggie and then Maggie with Bart, right? So it's listed kind of twice. So instead, how would we do this? The way that I would do this is you can say where C1.id, it's a self-join, right? So we know that the ID, right? Bart always has the ID of 1. So I'd say where C1.id, and you can do either direction, but let's just say is greater than C2.id. So basically what this means is like this case isn't going to exist anymore, right? Because Bart has an ID less than Maggie, but this one will, right? Because Maggie has an ID greater than Bart. Okay? So you're only going to get one half. You're not going to get it, right? You're only going to get each relationship pair once. And in this case, the direction of the relationship doesn't matter, meaning it doesn't matter if they're, these are effectively the same relationship, so this should work. And now this looks quite small, right, compared to what we were talking about, but I think this is right. Maggie is paired with Bart, and Maggie is also paired with Lisa, right? Those are the three kids. Bart is paired with both Maggie and Lisa is paired with Bart and Maggie. Okay, so you can. We kind of have to show you this because it's annoying to have to deal with this in an interview. So you can see, like in this case, by just doing the C1 ID is greater than C2 ID, we're able to create all possible combinations and remove duplicates, right? And also not pair the same student with themselves. Okay, what would be a use case of something like this? Like what would be like, what might be a question that kind of derives from this? What if they ask you, and let's just remove this from now. Select all from customers. So what if they ask us, okay, what is the maximum difference, or the least amount of difference in age between the three kids? Now, to do something like this, you want to compare each kid with every other kid, right? So think about how much easier this becomes if we do C1, select all from customers C1, join customers C2, where C2, or let's do C1.id is greater than C2.id. So now we're pairing every possible combination just once, right? And now how do we do it? Well, we subtract this birth year from this birth year, this birth year from this birth year, this birth year from this birth year, right? And then we'd get the differences, and then right from there we can find the max or the min, right? The minimum difference in age, if that's the problem. Okay, so this I'll leave for you all as like, I won't solve it, I'll leave it as a problem, but you basically get here and then you just start hacking away, right? And like you can use your knowledge of CTEs to basically get to the solution. Hey, questions about this, right? Cross joins is essentially where it's a way, we're not specifying the join column, and because of that, we're creating all possible combinations. A way when we're doing a self join with this, where we're joining the table on itself, right? We can kind of create all possible pairings, but we should make sure that we don't want to have those pairings twice, right? So we specify, have a where clause like this. Let me see. It looks like there was a question. Yes, you should, exactly. Conwell's got it. You should use an absolute value of differences. That's part of the trick. Cool. Cool. All right. So yeah, like I said, this will be, a problem I'll leave for you. I think that you can probably just take from here if you hack away with it. Next thing, let's actually do this problem first. So this will be, there's a typical, like, same way that you'll find like certain kinds of, Python, just like patterns or tricks. It's the same thing with SQL. So there's a kind of problem called a gaps problem in SQL. So let me show you what that looks like. Okay, so they'll give you a data set, and it could just literally be like a list of numbers, And what you can see with this list of numbers is that they're essentially sequential, but then there are gaps here, okay? So 1, 2, 3, here's a gap 4, right? 4 is missing. 5, 6, 7, 8, 9, 10, 11 is missing, right? 12, 13, 14, 15, 17 is missing, okay? And then the question is, basically you want to write a query that returns all of the gaps, okay? So let me show you, which is tricky. Like don't think I can solve this without having seen it a few times. So how do we solve something like this? So select star from numbers. We're going to join numbers again, okay? And we're going to say, if I join numbers on, let's say, I'm going to do that. Let's give them both an alias. N1, join numbers, N2, right? Because it's self-join. On N1.number equals N2. Let's just start here, N2.number. Okay. Now in this case, right, each of the numbers are the same. What if instead we do N1.number equals N2, let's just do this one, .number plus 1. Okay? So we should do, and I'll show you why, we should do a left join. All right. So in this case, we have n1 dot number, that's number 1. But number 2, is this right? Yeah, number 2 equals n2 dot number plus 1. Hold on. So we have ID 1. Here it's 0 and 1. Yeah, and then I think this case will always be nil. No, I think it might be this one. Sorry about that. Let's think about this. So we have select all from numbers where n1 dot number, yeah, equals n2 dot number plus 1. So in this case, there is no 4, remember, right? There's just a 3 and a 5. So when it goes to join this number, this n2, this n2 plus 1, I'm just a little... Oh, you know what?
Did you left join N2 on N1?
Left join numbers and 20.
No, never mind. I thought the order might
Let
have
me
been
also
screwy.
just do n1 dot number, comma, n2 dot number. I think it is giving me the right answer, which is nice. So here, I'm just confused as to, here we have 2 is lining up with 1. Oh yeah, the number is actually, the number I would think would be the same. Let's try minus 1. That should be, it should not matter actually. Okay, so here's n2, yeah, okay, now I get why this works, okay. Because n2, so when the number is 2, right, then it's going to be 1, and 1 is going to match with 1, okay? And then when the number is 3, here it's 4, right? And 4 is going to match, and right, and there is no 4, right? So you get a not a number here, okay? So in this case, and then for the last number, when it's number 17, it's looking for 17 minus, 18 minus 1, which would be 17. It would be 18 that would match, but there is no 18 because it only goes up to, right, the data set only goes up to 17. So in this case, I guess it's a little bit easier to understand. We're always looking for one more, right? Is there that next number, right? In this case, there is a next number. In this case, there is a next number. In this case, there is not a next number, right? There is no 4. So let's just solve it this way for now. So you can kind of see how we do this. Left join. The next thing we just have to do is say where n2 dot number is not null, right? Where this column, or no, is null, because that's where we're missing our data. So you can see what we're getting to now is 3, 10, 15, and 17. I think I have the answer here. The answer that we want to get to is 4, 11, and 16. So how do we get, and you remember why we're getting this as 1 less than. It's because when this is number plus 1, so it's looking for a 4, and it's getting a none here. So how do we kind of get this to show the result that you want? Again, you kind of just hack away. So we can do n1 dot number plus 1, right? And that will give me 4, 11, and 16. And then it gives me one additional one, so we can call this kind of like as result, whatever you want. Okay, and now it's always going to give me this additional one, right? Because this is, was originally a 17 and it's looking for an 18, but the data set ends at that. So what you can do is and select max, right? Max of the list of numbers dot n1, and so this should give me back the 17, and you just want to say where it's not, the max number, something like that. So say select and where numbers is null and n2 dot number does not equal the max number here. And I broke it. No such column numbers dot n1. It should be n1 dot number. A misuse of action. This is a subquery. So should say from numbers. Select max of number from numbers. So this is a subquery, so we're basically just finding the max, right? And then say, hey, don't give me back the result where we have, don't give me back that row where it should be where n1 dot number is 17. So this is giving me that answer. I can do this one more time if it's helpful. But essentially what we're doing is you start with a list of numbers, select all from numbers. Okay, so we get the full list. Let's just do select number from numbers. And we can see that there is that when we pair it, join, we'll do n1, join numbers n2 on, and now we can do, I forget what I did last time, it was the minus. You can really do it either way, it doesn't matter. But I just want to show you this one technique first. So you just do 1 minus, n2 number minus 1. So what this will do is it will actually match the number 2, right? Because 2 minus 1 is where they're equal. So it's going to match this case of 2. So that'll be n1, we'll just do n1 dot number for now, comma n2 dot number. All right, and now you can see the 2 matches, right? Because 2 minus 1 is 1, and so they join. All right, now where is there not a sequential number? It's in the row 3 to 4, right? So let's do a left join so we can get those null values. So here in this case, there is no sequential number, and you can see that this is returning a null value here. So the first thing, and it's also always going to give us this extra number down here, okay? So if we want to get rid of this, I'll do this part first just to help. What you can basically do is get the max value and say, let's return all the numbers where it does not equal the max value, right? Where this does not match the max value. So we can do where, let's go to the next line, where n1 dot number does not equal, select max of n1 dot number from numbers. I should just say select max of number from numbers. So where n number does not equal, select max number from numbers. I think that's okay. I'm breaking on a syntax number.
I think you have to give it an alias once you do the subquery, maybe.
Right here, I don't. No, where n1 dot number does not equal, select max.
Well, you're fine there.
n1 dot number does not equal, select max number from.
You're missing a parenthesis.
I have an extra thing right here.
Hmm.
Yeah, I think that was the issue. Yeah, don't try this at home. So yeah, this will be fun on an interview, all the parentheses. So, okay, so I think that got rid of it, right? And now you can see that we can just, like, we have this pattern. So you just say, like, n, the next thing would say, and, right, where 1 is not that max value, and n1 dot number is null. Or sorry, it should be n2, right, because this is this one. And that's what we gave the alias. And now you can see that we're 1 off, right? Because the 3 is trying to match with the 4 here, but there is no 4. So this is kind of like representing that missing number. So what we can do from this point is just add 1. Okay? So n1 dot number plus 1. And you can just call this like whatever you want as result. Okay, and then we don't need this. We don't need to show this none here, so you can just get rid of it, right? Okay, 4, 11, and 16. Okay. So there, believe it or not, like this stuff, there's a gaps problem and there's like an islands problem. We won't do the islands problem today, but like I said, like this is like one of these like typical kind of somewhat more typical SQL problems. So I wanted to make sure you know how to approach it. The main thing that I do is I just know that I can do a self join it on itself. And then, like I said, it actually does not matter, and the reading shows you this. If you do what, n2 number -1 or you do +1, they'll both work. They're both just variations on each other. The reading walks you through both of them, so you'll be fine. And then from there, you just, like I said, my approach from there is just hack away, meaning like we'll need to add 1 to get the ultimate result, and we'll have to remove that extra digit, right? Yeah, Conwell.
Yeah, I have a quick question regarding the subquery we have over here. So where n1 dot number not equal to select max number, I just wanted to understand the execution plan for this subquery. Like, will this be executed for every record from the joins result set, or this will be executed just once?
I don't. Let me think about it. So I think this only has to occur once, and I think this will occur first. So it's kind of like you're basically loading the table up 3 times, right? Notice I'm not using the alias, like I'm not doing n1.number. Like this is a third load of the table. So I think this will actually happen first, and then we will do the join, and it will compare, not do, check the where clause to make sure that it does not equal this number. So I think this, I'm not, you'd have to like look at Postgres to actually see the execution plan, but my guess is this will happen, this will be the first thing that happen is executing the subquery. Cool. All right. There is one more topic I wanted to cover, but I think maybe we're pretty good. Yeah, so we can leave it there. What I'll give you to do is cross joins. So that will, you can go through that reading, do that kind of challenge problem at the end. This is actually kind of challenging, these advanced joins. I think they are. So I'll also deploy the solution just right away. And then you can do this gaps and self joins, right? That's essentially the exact same problem that I just gave you. And then this is the last topic I wanted to cover for you. I think maybe we'll do that next class. So if you finish early, again, I think these types of I'll give you also this SQL LeetCode fundamentals. This is like another set of like classics. It doesn't involve any new material. It's just kind of like classic problems you'll run into. I think they're good problems to like review again and again, honestly, the ones in this lab. And then either the end of this class or next class, we can go through correlated subqueries. All right. Cool. All right, we can do breakout rooms.